I'm Mark Cartwright from NYU, and I will be presenting DCASE 2020 Task 5, Urban Sound Tagging with Spatiotemporal Context. So often in machine listening, our training and evaluation data is scraped from the web. We treat each recording as independent of any context. However, in many real-world machine listening applications, the recordings do come from a particular context. For example, we may know when and where they were recorded, which may provide clues as to what sounds we should expect to hear. For example, cities like New York are complex systems with lots of seasonal periodic activity, and therefore soundscapes from the city contain seasonal periodic sounds that reflect that activity. For example, there's honking at rush hour, the clang of garbage trucks on Monday morning, children playing after school, church bells at noon, Shabbat sirens on Friday, summer concerts in the park, and the dawn chorus of birds. These are all examples of the sounds that define the city soundscape and represent the spatiotemporal structure of city life. So in Task 5, we wanted participants to leverage this knowledge and to investigate if spatiotemporal metadata can help in urban sound tagging, which can then be used for building systems to monitor urban noise pollution. So to do so, we have developed the Sonic UST v2 dataset. This dataset has over 18,000 recordings from 56 sensors in our Sonic sensor network, recorded between 2016 and 2019. This is over 15,000 more recordings than the previously released version of this dataset. And each of these recordings has been annotated with 23 fine level urban sound tags from 8 coarse level categories. And each recording was annotated by 3 volunteers on the Zooniverse citizen science platform. And a subset of 1,380 of the recordings have been verified, have verified annotations by the Sonic team. And of course, for each recording, we also have included spatiotemporal metadata. And this data was in the form of spatial location, quantized to the city block level, and temporal location quantized to the hour expressed as hour of the day of the week, week of the year, and year. Lastly, when using this data in training models to predict tags, we strongly encourage participants to use external data to help inform the model, including data sources such as land usage, traffic data, weather, construction permits, social media, etc. And many of these forms of data are easily available on New York City's open data portal. So we had 22 systems that were submitted by 6 teams. And most of these systems used a CNN or a CRNN with spectrogram inputs. And most systems increased the training data using augmentation techniques such as mix-up, scaling, shifting, and masking. And some of the systems also used models that were pre-trained using external data such as AudioSet and ImageNet. And then all the systems used temporal context that we provided. And most of the systems also used the spatial context as well. However, none used this spatiotemporal context to query external data sources as input, as I discussed in the previous slides. And we suspect this was too much to ask for a community that's used to working strictly with audio data. We're hoping to attract participants from outside the audio community who would appreciate that challenge. That didn't seem to happen. So we evaluated the systems at both the coarse and fine levels, macro AUPRC as our primary metric and micro AUPRC as our secondary metric. And the top 2 performing systems were Arnal and Iqbal. They were both quite close to each other, with Arnal performing a bit better at the fine level for the primary metrics, while Iqbal performed better on both coarse and fine for the secondary metrics. So yeah, please check our results page on the DCASE website for additional details on how all these systems performed. Thank you.